We're going to move into our shapes. Yesterday, we learned the names of the polygons. Now we're going to talk about quadrilaterals. Quadrilaterals are very, very important. Quadrilaterals, as a reminder, it is figures that have four sides, right? Polygons that have four sides. So, right, there's some special quadrilaterals, right? Anything that has a four-sided figure, it's a quadrilateral. Now, there's some that are specific. One of them is, let's talk about top side and bottom side are parallel. That means they never intersect. So, matter of fact, the way I'm going to emphasize they're parallel, I'm going to put arrows. So the same arrow in each. That means those two sides are parallel. Top and bottom are parallel. The left and the right, the other two sides are also parallel. But in this case, to emphasize, I'm going to use two arrows. So you're going to see those. All right, top and bottom are parallel, left and right are parallel. We're going to call this parallelogram. Top and bottom are parallel, left and side are parallel. Now, parallelograms, there's other parallelograms that are a little bit more specific. So I'm going to show you a few figures that are also parallelograms. So let's talk about a parallelogram. So let's just say top and bottom are parallel, the sides are parallel. But now this other parallelogram, the interesting part of parallelograms on this other one is that all the angles are 90 degrees. Now that one we're going to call a rectangle. So a rectangle is still a parallelogram, but a little more specific name is rectangle. Another parallelogram that we know is something that we called rhombus. Let me write the name first. Rhombus. Now a rhombus, it's a parallelogram where all four sides are equal, not necessarily the angles. I know in kindergarten, some people call this diamond. As a matter of fact, let me do slashes to represent all the sides are equal. Right? The angles don't really have to be equal, but the sides do. Now, the interesting part is that there is one parallelogram that it's a combination. It's a combination of a rectangle, it's a combination of a rhombus. So it has to have all four angles 90 degrees, all four sides equal. So it should look something like this. The angles are 90 degrees because it's a rectangle. But because it's a rhombus, all the sides are equal. I'm going to represent sides with little slashes. Now this one, we're called this square. So all of these are parallelograms. Parallelograms, again, it could be a rectangle, it could be a rhombus, or more specific, it could be a square. Some of them are just parallelograms. They're not a rectangle, they're not a rhombus. Obviously, they're not a square, they're just parallelograms, right? We're going to talk about the names. Let me talk about other shapes that we know that are four-sided figures. One of them is called trapezoid. Now, for a trapezoid, what we have is the top is parallel with the bottom. So I'm gonna do arrows to indicate they're parallel, but one of them is bigger than the other. So the two things at the side, obviously they're not parallel. If you were to extend them, they will eventually meet. So only top and bottom are parallel. Now this one we're gonna call trapezoid. There is another one, there's a special kind of trapezoid. So trapezoid, the top and bottom are going to be parallel, right? So let me draw a trapezoid here. But the interesting part of this other trapezoid is that the sides, these two that are not parallel, they are the same size. Now this one we're going to call isosceles trapezoid. Isosceles trapezoid. So a trapezoid could just be a regular trapezoid, or it could be an isosceles trapezoid. What makes an isosceles trapezoid is that the sides that are not parallel, we call those legs, those two sides are the same length. If they're the same length, isosceles trapezoid. If they're not, just trapezoid. Now there's one shape that we learned back in kindergarten, kind of looks like a rhombus. It's just that the bottom is extended a little bit more. So now on this other shape, the top two sides are equal. The bottom two sides are equal. So I'm going to do slashes to represent they're equal, but not all four. Okay, so the top two are equal. The bottom two are equal, but not all four. This one, we're going to call it kite. Right, you guys learned about kites back in kindergarten. Those are the shapes that we're going to be using. Now, notice that in this case, I was using slashes to represent sides were equal. Now, sometimes I might use a slash, sometimes I might use measurements. Interesting part, when I say measurements are actual numbers. Interesting part of parallelograms, the sides that are parallel are also equal. So for example, the side on the top was 10, side at the bottom is also 10. Not only they're parallel on a parallelogram, not only they're parallel, they're also the same length. I could say the sides, the left and the right are 7, right? These numbers are just examples. So again, the sides are not only parallel, but they're also the same length. Another interesting part on the parallelogram when it comes to angles is that the two angles on the left, let's say this is 100 and this is 80. Those two angles are going to repeat on the other side. It's just going to be flipped. This is going to be 80 and this is going to be 100. The idea on a parallelogram is when you connect two angles that are next to each other, we use the word adjacent, right? So if you look at two angles that are next to each other and you add them up, it will give you 180. Pretty cool. So same thing with rectangles and rhombus and obviously squares. Like I said, I could use measurement, I can use lashes, or I could actually use numbers. For rhombus, for example, you notice I use lashes to say all the sides were equal. I can literally represent this by numbers. I can say this side is 3, this other side is 3, 3, and 3. Right? I could use numbers or I could use lashes. Okay. Now, on the trapezoid, interesting part on the trapezoid is that the two angles on the left have to add up to 180. Kind of like they do in a parallelogram. So let's say this is 100, this is 80. On the other side, they also have to add up to 180, but not the same numbers. So I could just say this is, let's say 110, and this is 70. So notice two adjacent angles, two angles that are next to each other, don't have to add up to 180. Now for an isosceles trapezoid, let's say this is 110 and this is 70. On the other side, I get the exact same angles. So notice for just a regular trapezoid, the angles on the left and the angles on the right are not equal. On an isosceles trapezoid, they are. When it comes to kite, there's only two angles that are going to be equal. These two angles. Now, don't think I'm going to give you guys a figure standing up. I'm going to rotate them. So let's take a look. I'm going to be working up until number 44. So number 41. I look at, in this case, I have numbers. I see one side is 11.2, 11.2, 11.2, 11.2. All the sides are equal. So I'm going to call this rhombus. Right? It's a parallelogram, but it's also rhombus. A little more specific rhombus. If the angles were also equal, I would have called that a square. Let's take a look at number 42. That looks like a trapezoid. It just tilted. Interesting part is that I'm going to call this the two angles of the side, and these are the two angles of the side. Notice how they repeat. So I'm going to call this isosceles trapezoid. Right, that's an isosceles trapezoid. So it is a trapezoid, but a little more specific, isosceles trapezoid, because the sides are equal. The 9.8 sides are equal. So that could be given numbers, but let's take a look at given just marks. I notice all the angles are 90 degrees, but not all the sides. Therefore, I'm just going to call this rectangle. Right, this is a rectangle. And looking at the question number 44, kind of looks like a kite, kind of, but in order for this to be a kite, for me to know, for example, these two sides have to be marked, these two sides have to be equal, but in order for me to say they are equal, they have to be marked to begin with, and they're not. Now, in this case, it's neither, I look at my list, it's neither of those, right? It's not a parallelogram, it's not a rectangle, it's not a rhombus, not a square, not a trapezoid, isosceles trapezoid, or a kite. It's neither of those. Therefore, I'm just going to call this quadrilateral. It has four sides. So there's a list of special quadrilaterals. But if it's neither of those lists, and when I say a list, looking at number 40, right? That's a list. If it's neither of those, but it still has four sides, we're just going to call this quadrilateral.